Chapter 5, Section 3, more on factoring trinomials. We're going to go over different methods to factor trinomials, including the grouping method and kind of what we sometimes call the reverse FOIL method to factor trinomials whose lead coefficient is not a 1. In section 5.2, those were the types of trinomials that we were factoring. So I want to make mention of an expression in a very famous book when I talk to students about their factoring skills. And that expression is to separate the wheat from the chaff. In fact, I think I used it in the last video. And what I mean basically is to try to determine which students can factor trinomials to those that cannot, because it's such a valuable skill. So what we're going to do is we're going to look at different approaches. You're going to find one that you think works for you, and then that's the one I would spend most of my time concentrating on. Now, it's nice to be able to factor using a variety of methods, but you want to just make sure that you have one of them that you have figured out pretty well. Okay. Now, the first approach is what is called the grouping method, and this is for factoring trinomials where the lead coefficient is not a 1. Okay. So what we're going to do is we're going to kind of use the same grouping approach that we had in section 1 of this chapter. But normally, when you're grouping like that, you need 4 terms, and a trinomial only has 3 terms. Remember, terms are separated by plus signs and minus signs. So what you're going to do, first off, identify A, B, and C here. A is the coefficient of the x squared, B is the coefficient of the x, C is the constant term. So they are 3, 10, and 8 respectively. And then take A and C and multiply them together. So if I multiply 3 times 8, I get 24. Now, what I want to do is I want to look for pairs of factors of 24 that add up to the middle coefficient, the B, in this case the 10. Well, as it turns out, if you go through the list of possibilities, because it's got to be a positive 24 and it has to add up to a positive 10, you know the numbers are both positive. And in this case, it'd be 6 and 4. 8 and 3 adds up to 11. 12 and 2 adds up to 14. They're just not going to work out. 6 and 4 works out. So what we do is we take the middle term, the 10x, and we break it apart into 2 terms with coefficients of 6 and 4. So we're going to take the 10x and we're going to break it into 6x plus 4x. Now I know that seems kind of weird, but if you do it that way, look what kind of a polynomial you have. You have 4 terms. Now, on this guy, I approach this using the grouping method from back in section 5.1. So I'm going to group the first 2 together. I'm going to group the last 2 together. And remember, you're trying to match the binomial, so take the GCF out of the first 2, which would be 3x, and that would leave x plus 2. Take the GCF out of the last 2, which is 4. If I factor that 4 out, if I use the distributive property in reverse, I have x plus 2, and the x plus 2's match. So now I factor out the x plus 2, and that leaves the 3x plus 4. And I have factored this trinomial into a product of these 2 binomial factors here. Now, you can check it. You just have to use FOIL. So if I check this, and I've got that checked for you here, if you take the x plus 2 and the 3x plus 4 and do FOIL, look at that. Son of a gun. The same original, where's it at, where's it at, where's it at? There it is. The same original problem there. Okay? Now, I'm not crazy about that method. It's not bad, and in some cases, your teacher will say, here, put a diamond like this, and put what it has to multiply to be, and put what it has to add up to be, and then you kind of think of which numbers. Oh, 6 and 4. 6 times 4 is 24, 6 plus 4 is 10. Sometimes they call that kind of like the diamond method or the cross method there. I don't know. I'm not as much of a fan as this as I am the next 2 methods, although I have taught plenty of students this this approach, and they've handled it quite well. Now the trick is coming up with the pairs of factors so that you can see what pairs of factors of A times C of these 2 numbers multiplied together, so we can determine what 2 add up to that middle term, that middle coefficient. All right, now method number 2, I was taught by a guy years ago that I worked with at An old school of mine, where's that? There we go. There we got it. And he called it the bottoms up method. I don't know if it's got a better name than that, but I just, for good old Ronnie Webb, it's the bottoms up method. And the bottoms up method, we're still starting with ax squared plus bx plus c. This is still not equal to 1. And we start out very much like we did the last problem. We take the a and the c and we multiply it together, but we don't just write it as a number over here. We take the a times the c and we leave it there. So we remove the a and multiply it times the c. So that gives us something that's similar to what we would have had in the last section. And we break this apart with an x and an x and try to find two numbers whose product is this, whose sum is this, and so on. But once we have done this, we have changed the problem. So even though we might be able to get it to factor, that's not what this guy, the original, factors into. That's what the changed trinomial factors into. So because we multiplied by a, we have to undo that step, and we'll take both of these numbers and we'll divide by a. We'll simplify them if necessary. If you have like a fraction, if you get an integer, just write it as an integer. If you get a fraction, make sure it's in simplest form. And then if we do have a denominator in a fraction, as the example is here, see how I have x plus 2/3 and x minus 5? We just bring the denominator from the bottom up in front. And we write it as 3x plus 2. Hopefully you can see that okay. Now, I'm going to show you an example here in just a second of this, but that's the approach that we'd use when we're doing the bottoms up method. So let's go back to the problem that we did using the grouping method and see if we can still get the same answer. Remember what the answer was back here. The answer was the quantity x plus 2 times the quantity 3x plus 4. So let's see if we can get that. So I bring it over here. All right, my lead coefficient is a 3. I take it, I multiply it times the 8. So that would give me x squared plus 10x plus 24. Now this actually will factor. Well, at least you hope that it will factor, but it will factor in a way where we do an x and an x. We find two numbers whose product is 24, whose sum is 10, and that would be positive 6 and positive 4. So we put a plus 6 and a plus 4. But we're not done, because that's not the answer to this. That's what this factors into. To get to see what this guy factors into, remember how we multiplied by 3? Well, now we've got to get rid of that. We've got to undo that multiplying by 3. And to do that, we take the two constant terms in the binomials and we divide by that constant, by that value of a. We divide both by 3. Now this first guy here, 6 over 3, simplifies down to 2. So that's just x plus 2. This guy doesn't simplify. It's an improper fraction, granted, and I'm not going to write it as a mixed number, but I can't divide top and bottom by anything to simplify it. It's just 4/3. So here's where they get the name bottoms up. We take this from the bottom, from the denominator, and we bring it up in front of the variable x. So this 3 goes in front of the x there, plus 4. And did we get back to the same answer? Yes, we did. Same answer as before. Now, I think this is a little bit easier, but it kind of just depends on what you've been practicing. Now, I don't think it's the fastest way to do it, but it might be one of the faster ways to do it when you're first learning factoring. Now, I know there are websites that you can go to and you can enter in your trinomial and it'll factor it for you. But you're not always going to have that luxury, because there's still some math instructors at the universities that are still kind of old school, and they're going to have you show your work without the use of your phone, without the use of a graphing calculator of some type, without the use of a computer. And they're going to expect that you be able to do some of this algebra on your own. So it would not hurt to practice. So anyway, that's what this guy is equal to. This is just scratch work. This guy equals this guy. Okay? And that, again, is called the bottoms up method. Now, the method that I was taught by my algebra teacher many, many years ago, he didn't call it reverse FOIL. He called it trial and error. Now, I've heard teachers call it the guess method. I've heard them call it trial and error. And I've heard them call it reverse FOIL, because it's kind of like doing the FOIL problem backward. Instead of multiplying two binomials to get the trinomial, you have to break the trinomial down into the two binomial factors. And this is the way I was taught by my algebra teacher, good old Mr. Halfer. And I remember students in my class struggling with it, but those that stuck it out, for the most part that I can remember, actually did pretty well with this. And this method, although it's a pain at first, is, after a little bit of practice, a fast way, an efficient way to factor trinomials. Now, it's based on the lead coefficient and the constant term. You have to find factors to break into your two binomial factors. You have to find numbers that divide into A, the numbers that divide into C. And that way, we're going to try different combinations, trial and error, until we get the right combination so that when we multiply back, we get where we started from. So here's what I'm going to do. Same problem again. We should have this one figured out by now. 3x squared plus 10x plus 8. And I'm going to use reverse FOIL. Okay, I'm going to try to trial and error my way here. So I look at this number here, and the only two numbers that divide into 3 are 1 and 3. However, 8 divides into either 1 and 8 or 2 and 4. So I just have to figure out which one it is. So normally what I do is, since it's 1 and 3 here in front of the x squared, I put 1x and I put 3x down. I just have to fill in the holes here, because that's really the only way. Now you say, well, what happens if instead of a 3 here, what happens if it was like a 10 here? It could be 1 and 10 or 5 and 2. Well, then you have to try the different combinations. That's why it's sometimes called trial and error. Although I usually start with the numbers that are closest together. I'll talk about that again in a second here. So I have x and I have 3x here. And what I'm going to try to do is I'm going to try to figure out what two numbers go here so that when I do the O and the I in FOIL, I get to my middle term. Because I'm going to get the ends to work, because I'm picking factors of 8. And I know x times 3x is going to be 3x squared. So I know the f in FOIL is going to work. I know the L in FOIL will work. I just have to figure out which ones, so that when I do the O and the I get 10x in the middle. So, coming over here, this is what I have so far. I have the x and I have the 3x. Now remember, my choices were 1 and 8 or 2 and 4. Now I normally, as I'm kind of writing here, if I have more than one choice, I usually start with the two numbers that are closer together. I don't know why, but it just seems like a lot of algebra books pick those as the numbers. They pick problems where it's the two numbers that are closer together. It seems like it's 75% of the time. So I'm going to start with a 2 and a 4 here. Now, the key is, do I put the 2 here and the 4 here, or do I put the 4 here and the 2 here? Well, the first time I tried it, I put the 4 here and the 2 here. I put the 4 plus 4, because it's positive 4, positive 2, and the plus 2 here. But when I did the O and the I got 2x and I got 12x, positive. That doesn't add up to 10x. Remember, it's got to be the 10x in the middle. So that was no good. I had to try a different combination. So that's why they sometimes call it trial and error. So then I switched the 4 and the 2 around. I put the plus 2 with the x and the plus 4 with the 3x. And I tried the O, that's plus 4x, and the I, and that's plus 6x. Well, plus 4x plus 6x is 10x, and that's the one that works. Now, you look at that and you say, I don't know, I kind of like maybe the bottoms up method better. That way I don't have to sit there and trial and error, because you can get a lot of combinations based on what the first number is in the trinomial and what the last number is in the trinomial. It could have lots of different pairs of factors. You know, and you could be at it for a while until you exhaust all the possibilities and either find one or find out that it doesn't factor. Now, there are some things that will help you, and I have a few of them listed right here. This will help you. If the number in front of the constant term is a negative, you know the signs are different. In here, the signs will be different. One will be a plus, one will be a minus. You're not sure which ones get which, but you'll know signs are different. If the sign is a plus in front of the constant term, then the signs are the same. If it's a plus here as well, they're both positive. If it's a minus here, they're both negative. So that'll help you a little bit. There's all sorts of subtle things that you can practice to get better at using this reverse FOIL or this trial and error method. So now I have some examples that I'm going to try to do each of the different methods with. First example here, and I'm going to do this one with grouping here, is that I'm going to take 15x squared plus x minus 2, and I'm going to take the product of 15 and the product with negative 2 here, and that gives me a product of negative 30. My sum is 1. So I got to think of two numbers that multiply and give me negative 30 that add up to give me 1. Well, because it's a negative here, that means these two numbers are going to have different signs. And because it's a positive in the middle, I'm going to have the bigger number have the positive and the smaller number have the negative, absolute value-wise bigger and smaller. So I'm looking at this and I'm thinking 6 and negative 5. 6 plus negative 5 is 1. 6 times negative 5 is negative 30. So I am going to rewrite this as 15x squared plus 6x minus 5x minus 2. The 6x and the minus 5x, that's the 1x right there in the middle. Now I'm going to do grouping, first two and last two. The first two have a 3 and an x in common. That'll leave an x, and, or excuse me, a 5x. Heavens to Murgatroyd, almost messed that up. A 5x, and that'll leave a plus 2. Now these two guys don't really have anything in common other than 1, but I noticed that the sign here is plus plus and the sign here is minus minus, so I'm going to factor out a negative 1. And that'll change the signs, because remember I'm trying to match the binomials with the FOIL method, so that'll give me a positive 5x and a plus 2. Alright, now I can factor out the 5x plus 2, and that will leave 3x minus 1. And there you go. Now, if I wanted to do the same problem using the bottoms up method, I take the 15 times the 2, so that would give me x squared plus x minus 30. I factor this like I did in the last section, an x and an x, two numbers whose product is negative 30, whose sum is positive 1. That sounds familiar. Very similar methods. So that would be a plus 6 and a minus 5. And then because I multiplied by 15, I have to divide both of these by 15. And notice both of these are going to reduce. I'm going to get x plus, that's 2/5, divide top and bottom by 3, divide top and bottom by 5, x minus 1/3. And then bottoms up for both parts. Bottoms up there, bring the 5 in front of the x and bring the 3 in front of this x. So I have 5x plus 2 and I have 3x minus 1. And son of a gun, that's the same method. Now, if you're going to do this one with trial and error, you'd have to think of, okay, what could 15 be? It could be 15x and x. It could be 5x and 3x. What could 2 be? Well, it's got to be 2 and 1. So it's just a matter of getting the right combination here, and we've already kind of see that one coming. Now again, this is probably the least appreciated approach to factoring when you're learning factoring really for the first time or just trying to get better at it. One of these two methods seems like students for the most part like a little bit better, but you can use trial and error here. Okay? All right. Now, what happens if there's two variables? Well, we've had this happen to us before. What we're going to do here is work it the same way. It's just that when we write our binomials, we'll have x's in the first terms, we'll have y's in the last terms. So if I'm going to approach this problem, let's say I use bottoms up here. I'm going to multiply 8 times the negative 5. That would be x squared minus 6xy minus 40y squared. So let's see if I can break this one down. That would be an x and an x. And I need two numbers whose product is negative 40 and whose sum is negative 6. I'm thinking negative 10 and positive 4. You multiply, you get negative 40. You add them, you get negative 6. So I'm going to write minus 10y plus 4y. That's how I pick up the y squared there and the y in the middle. Remember, I multiplied by 8, so now I got to divide by 8. Both numbers. And again, just like in the last example, neither one of these simplifies to an integer, but you can simplify. You can divide top and bottom by 2. That would be 5/4 y. And you can multiply or divide top and bottom by 4. That would be x plus 1/2 y. And then, bottoms up, we bring it out in front. And I get 4x minus 5y times 2x plus 1y, or plus y. Now, if you're wondering, well, how do I make sure that this is the answer? Well, you check it. You do FOIL on this and see if you don't get back to the original problem. Now, in this next example, this one has a GCF. So what I'm going to do is I'm going to have to first remember to factor the GCF. Now, in the last section, I kind of made a big deal about this right at the end of the video because I was talking about always check for your GCF. Well, I know I didn't say it verbally, but trust me when I tell you, every one of the trinomials that I factored up to this point, the very first thing I looked at was to see if there was a greatest common factor. I've just taught myself to do that. I don't always state it out loud, but I'm telling you that's something you always have to check for. So, and this one has a GCF. It looks like it is a 3z to the 4th, because 3 goes in all of those, and there's at least 4 factors of z here. So that would leave 5z squared plus 6z minus 8. And now, on this guy right here, this guy, I'm either going to use trial and error, I'm going to use grouping, or I'm going to use bottoms up. So in this case, I haven't done a trial and error one since that first example, so I'll see what I can do here. 5z squared, this is a good one for trial and error because there's only one way to break down a 5, and that's a 5 and a 1. There are a couple ways you could break down this 8. It could be a 4 and a 2, or it could be an 8 and a 1. And as I mentioned before, I like to pick the two that are closest together. It doesn't always work out that way, but I think it will here. So I have a 4 and a 2. Now I can put the 4 here and the 2 here, and I can put the 2 here and the 4 here, but I got to make sure that when I do this, that the O and the I will give me a plus 6z. And remember, I got to get a negative 8, so these are going to have different signs. Well, I'm looking at this, and I'm thinking, if I put a 2 here, and if I put a 4 here, this part would be 10z, this part would be 4z. Now remember, they're going to have different signs, and I need a plus 6 in the middle. If this is positive and this is negative, that's positive 6z. So I need this part, which is the 10z, to be positive. So I'll put the plus there, and I'll put the minus there, and boom, there is my answer. Now, I've practiced this a lot, so I'm better at it than the average algebra student. However, you don't have to do this. If you stick with it and practice it, you can get pretty fast at it. And that's what really helped me out in high school math, and even to a certain point in some things in college, was that I was pretty good at factoring. And that was an important skill to have. All right, last guy here that, oh, wait a minute here. I've got some more examples over here. Oh, man, how did I skip these? All right, well, we'll do these after this one here. It says one more, but let's say 2 more after this one more. All right, again, GCF. It looks like it's got a 2 that goes in all of them. It has an x that goes in all of them. But because my lead coefficient's negative, I'm going to factor out a negative 2x. That will leave a positive 12x squared, dividing it out, minus 16xy, minus 3x, took out the x, minus 3y squared. And now I'm going to try to break this one apart. Let's see. Well, the 3y squared is easy. That's 3y and y. I could go 12 and 1, 6 and 2, 4 and 3. I usually like to pick the ones that are closest together, but I got a pretty good size number in there. Not sure if a 4 and a 3 is going to be big enough to give me that 16. I wonder if a 6 and a 2. I think a 6x and a 2x will here. I'm kind of running over these combinations in my head. Because see, if I put a 3y here and a 1y here, this is 18y, xy. This is 2xy. They have to have different signs for this to be negative. So I need a minus 16. If that's negative and that's positive, I got it. So this has to have the negative and this has to have the positive. Okay? All right, let's try a couple more here. We'll do, I've got one that says with reverse FOIL, but we'll do this one here using the grouping method here. So I'm going to factor this guy using the bottoms up method. I'm going to take the 12 and I'm going to multiply it times the 3. I get y squared minus 16y minus 12 times 3 is 36. And then I'm going to try to factor it with a y and a y. I need two numbers whose product is negative 36, whose sum is negative 16. Well, I'm thinking negative 18 and positive 2 myself. Minus 18 plus 2. And then because I multiplied by 12, I have to undo it by dividing by 12. And both of these reduce. I get y minus 3 over 2, divide top and bottom by 6, divide top and bottom by 2, y plus a sixth, and then bottoms up, bottoms up. And I get 2y minus 3 times the quantity 6y plus 1. And that is what this guy factors into. If you don't believe me, check with FOIL. All right, this time we'll do grouping here, because I haven't done enough of those. So here's one more here. I got two of the pages backward there. Sorry about that. Still good problems. All right, so we take the 8 times the negative 5, we get negative 40. It's got to be a negative 6 in the middle. So I am looking for two factors of negative 40 that add up to negative 6. And I'm thinking negative 10 and positive 4. So I am going to break negative 6x down to 8x squared minus 10x plus 4x minus 5. Group and group again. These have a 2x in common. That leaves 4x minus 5. Well, they only have a 1 in common. Plus 1 times 4x minus 5. All right, you can see the 4x minus 5 is common to both. 2x plus 1. Now, doesn't matter which method you use, but you need to get good at one of them. I might suggest either the bottoms up or the trial and error. I will also tell you that there's sometimes, no matter how many trial and errors, no matter how many different ways you approach it, sometimes trinomials just don't factor. So you have to be aware of that. It doesn't mean you've done something wrong. It just means it might not factor. Now, that doesn't mean every time you look at a problem and you don't want to spend any real serious time or thought about it, you just write down prime or it doesn't factor. You have to check them out and you have to practice, and that's how you're going to get better at them. Especially factoring is by practice, practice, practice.